Hi guys, this is Mrs. Rona here for another mini lesson on the periodic table. So if you want to do me a favor and grab a marker, you're gonna, 4 colors is what you want to be. So if you go ahead and outline this whole section, we're gonna go ahead and label this your s orbital. Now you have one little guy over here that's gonna be sitting with your s orbitals. So all those are s orbitals. Take your second marker, and you're going to go ahead and label as your p orbitals, and that's going to be group 13 through 18. Okay, so same thing, go ahead and completely outline this whole section as your p orbitals. You're going to go ahead and get your third marker color, and we're going to go ahead and label this as your d orbitals. And it's all this section right here. And then last but not least, your f orbitals. It's all these down here at the bottom. Okay, so you're gonna go ahead and have all these labeled. Now I wish I could put pencil colors up on my board, but I can't. So I'm gonna end up having to reuse these colors. But for you guys, I would recommend that you get pencil colors or crayons, and don't pick anything that's too hard where you can't see through. So I'm just gonna kind of reuse my markers. I'm gonna go ahead and label them. All right, so next right here, you're gonna color code the metalloids. It's easier to start here because of that stair step line. So that's gonna be boron, silicon, germanium, S9, tellurium, polonium, and S9. Okay, so these are going to be your metalloids. Everything to the right of it is going to be your nonmetals. So go ahead and color all these nonmetals. Okay. And then everybody else is going to be your metals. So go ahead and color code them in. So whatever color you're using, make sure that it's not too dark where you can't see them. I probably should have just gone and just did a quick swoop over there, but I've already started doing this, so I almost feel like I'm committed to continue doing like this. But those of you guys, I wouldn't color individually, I would just color straight across the periodic table. Now these right here are kind of iffy. I was looking them up, the 116, 117, 118. A lot of what I was reading is that 116, 117 have metalloid tendencies, kind of like semiconductors. And then 118, initially it was believed that it was a noble gas, but same thing, it's got these semiconductor properties. But because those guys only exist a fraction of a second, it's kind of hard to figure out exactly what their properties are. So just be careful when you look at them. Honestly, they're still very experimental, so chances are you won't have any questions on there. All right, so now that we've outlined them as my SPD orbitals, we have already labeled, color-coded my metals, metalloids, and nonmetals. The next part we're going to do is go ahead and put the oxidation charges. So group 1, actually let's do family names. Family name here for group 1 is an alkali metal, with the exception of hydrogen. Okay, group 2 is my alkaline earth metals. Right here, group 3 through 12, these are my transition metals. All right, I'm going to jump all the way over here to group 17. And these guys are known as my halogens. And group 18 are my noble gases. All right, so those are my family names. We're going to go ahead and put the oxidation charges on there as well. So everybody in group 1 has a tendency to have a +1 charge, which means they give up 1 electron. I look at my alkaline earth metals. This is right here, a +2 charge. Transition metals, because of that d orbital, it can go and share off more electrons. So we're going to go ahead and let him be for now. The way we'll know is going to be the Roman numerals when we assign it. So if it's like copper Roman numeral 2, that means it's a +2 charge. Copper Roman numeral 3 is a +3 charge. Boron right here is a +3 charge. The group 14 ±4. Group 15, -3. Group 16, -2. My halogens are -1. My noble gases is no charge. These guys are happy, so they don't really need to give away electron or gain electrons. All right, last little piece on here is going to be periodic trends. And all we're going to do is label the trends on them. We will discuss why in the next chapter. So as I go from right to left on the periodic table, my atomic radii is going to increase. And same thing going down my periodic table. I'm going to put my arrows for it always increasing, by the way. So this is my atomic radius. So what I'm saying is the atomic radius will get bigger as I go down the periodic table, and it'll also get bigger as I come across the periodic table from the right side to the left side. Now keep in mind there are exceptions to the rules where it'll change. So that holds true for atomic radii, but also the ion radii. Okay, they do have a tendency to do this. There are a few exceptions to the rules. When I look at my ionization energy, it's the opposite. They're going to increase from left to right, and from up the periodic table, going up the periodic table, they're going to increase as well. And the same is true for the electronegativity. All right, we will go through more of the property and the trends as we move along in the chapters. All I wanted to do was for you guys to already have your periodic table set and ready to go. So once we actually hit those parts of it, you already have it. We can explain why and move along. All right, hopefully that was a quick little introduction on how to color code your periodic table. You got any questions, please send me a message through Remind or through Schoology. Thank you.